Welcome! Today we want to talk about pricing. We will cover the 3 degrees of price discrimination and will consider pricing in the presence of network effects. Let's dig in. When a firm can charge a different price to each consumer, we call that first degree price discrimination. Depending on how much the firm knows about its customers, it can extract up to the entire consumer surplus. For a long time, first degree price discrimination was a purely theoretical idea. It was almost impossible to first know the willingness to pay of individual consumers and second, to put individualized price tags on goods. Digital technologies and the internet brought firms more and better data about consumer preferences and enabled one-to-one communication with consumers. There are a few examples where firms got bad press for first-degree price discrimination, like Amazon in the early 2000s. Consumers seem to perceive personalized pricing as unfair, and you will see in a minute why that might be the case. Hence, you don't see a lot of firms actively advertising that they charge personalized prices. But then it's also difficult to know whether I see a different price than you. So it could well be that many firms are actually using personalized prices. Often you see personalized prices framed as discounts or promotions, perhaps to make consumers feel better. Second-degree price discrimination is when prices are set so that consumers self-select into different pricing schemes. One way to achieve that is nonlinear pricing. Nonlinear pricing is common in telecommunication. Consumers can choose between paying per unit or a flat rate that is independent of how much they consume. Flat rate tariffs are particularly popular. Let's try to understand why firms like them. In the simplest possible pricing model, there is one firm and one representative consumer. Say the firm is a telecom operator. For simplicity, we can approximate that marginal costs are equal to 0. The demand function gives us the quantity demanded at a given price. The simplest model is linear. We can write inverse demand as P is equal to A minus B times Q. Now, what is the optimal price that maximizes the profit of the firm? Let's find the optimal quantity first, then plug it into the inverse demand function. The quantity that maximizes profits is the one where marginal revenue is equal to marginal cost. Revenue is price times quantity. Using the demand function, we can write it as A times Q minus B times Q squared. Marginal revenue is the derivative with respect to Q, which is A minus 2 times B times Q. This is interesting. The slope of the marginal revenue curve is 2 times B. The slope of the demand curve is B. When you want to draw this in a diagram, start with a demand function, and then add a curve for marginal revenue that is just twice as steep. The optimal quantity is where marginal revenue is equal to marginal cost. We said that marginal cost is 0, so the optimal quantity is where marginal revenue hits the horizontal axis. The profit maximizing price is the price that corresponds to the optimal quantity on the demand curve. Profit then is the area A defined by optimal quantity and price. Can we come up with other pricing schemes to make the firm even better off? Can we somehow increase profits more, meaning make area A bigger? The answer is yes, by using a 2-part tariff. Let's say our telecom operator is considering to offer a package with a fixed part and a variable part. The fixed part, F, is independent of the quantity purchased. Think of this as a monthly subscription fee. The variable part, P, is just a unit price. Total revenue then is F plus P times Q. So how would the firm gain from a 2-part tariff? What are the optimal values of F and P? Let's have a look at the same graph as before, the demand function in a price quantity diagram. The efficient quantity, where no consumer with a high enough willingness to pay to cover costs is excluded, is the one where the price equals marginal cost. Remember that marginal cost is 0. Thus, the variable part induces the consumer to consume the efficient quantity that maximizes consumer surplus. And that's the entire area under the demand curve. With this, what is the optimal fixed part? the optimal F that the firm should set. How can a firm extract all consumer surplus? By setting F equal to the area under the demand curve. This area is much bigger than the area A, which is profit under monopolistic pricing. Part of the firm's gains come from being able to extract more consumer surplus. The other part was previously left on the table, a deadweight loss, because it was optimal for the firm to exclude some consumers from the market. Let's extend the model and assume that not all consumers are the same. For simplicity, let's say that there are two types of consumers. Consumers with a low demand and consumers with a high demand. Their demand curves have the same slope, but different intercepts. In the simplest model, let's say that the firm can identify whether a consumer is of the low type or the high type. The best thing to do is to offer a different price to each consumer, to do first-degree price discrimination. The firm can extract all consumer surplus by offering the low type a low tariff at price A and the high type a high tariff at price A plus B plus C. What if the firm does not know whether a consumer is of a high type or a low type? Can the firm still extract all consumer surplus by offering the low tariff at price A and the high tariff at price A plus B plus C? The answer is no. The low type would still prefer the low tariff at price A, but the high type would make the following calculation. If she consumes the high quantity, this would give her a utility of A plus B plus C, but since the firm would charge a price of A plus B plus C, her consumer surplus would be zero. In contrast, if she consumes the low quantity, she would get a utility of A plus B, and since the firm would charge a price of A, her consumer surplus would be equal to B. As a result, the high type prefers the low tariff over the high tariff. In that case, the firm fails to extract the entire consumer surplus. If the firm sells the low tariff to both consumer types, it earns a profit of 2 times A. Does this sound too theoretical? Think of high types and low types in the context of air travel. Some consumers that could afford business class tickets will still buy economy class tickets. Hence, the airline fails to extract the entire surplus. Is there something the airline can do to make it more attractive for high types to buy business class tickets? Can we change the incentives for high types by offering a different pricing scheme? What is the price that would make the high type consume more than QL? One way to achieve this is to give a discount to the high type worth the exact value of B to make sure that the high type is indifferent between choosing the high or low tariff. So charging the low tariff at price A and the high tariff at price A plus C. The consumer still has the same surplus, but now the firm earns A with the low type and A plus C with the high type. Thus, the firm is better off. But can we make the firm even better off? Yes, we can. We can not only make the high type indifferent between the two tariffs, but we can make sure that the high type is in favor of the high tariff. We are not giving a discount worth exactly B anymore, but slightly more than B, such that the high type always has an incentive to choose the high quantity. We can do this by decreasing the low quantity by just a small amount and then offer the low tariff at price A prime and the high tariff at price A prime plus C prime. For the firm, this means that it will lose D but gain E, but D is smaller than E. So it can be optimal to decrease the quantity offered to low types to induce self-selection by high types. Back to our example of airlines. One way to incentivize consumers to buy business class tickets is to make economy class less appealing. That leaves only consumers who cannot afford business class to buy economy tickets. This brings us to the concept of third-degree price discrimination, a technique that uses different prices for different groups of consumers. While it may sound similar to business class versus economy class, it is not. With group pricing, we are not trying to make people self-select by setting a different price, but we are using the information that we have about customers on a group level to price accordingly. So, because we can identify different consumer groups and their willingness to pay, we can charge different prices. The classical example is the price discount that students get in museums. Here's another example. Orbitz, a travel website, realized that Mac users spend 30% more on hotels and thus started to show these users more expensive options. This can be considered as third-degree price discrimination because since Apple computers are more expensive, Apple users are likely to have a higher income. A user's computer setup can be a good indicator for their willingness to pay. Nevertheless, this price technique caused a bit of bad press, and Orbitz quickly clarified that it did not charge higher prices to Mac users, but only displayed more expensive hotels, as according to their seeming preferences. Finally, let's talk about dynamics in strategic pricing. Does the optimal pricing strategy change over time? The answer is yes, especially when you're operating in a setting where network effects are important. The idea is that a consumer's decision to buy your product does not only depend on the price, but also on how many other consumers have already bought it. You may want to start with a low price, even though it's initially not profit maximizing, because this will increase the quantity sold. More customers are better because they create demand-side externalities, network effects. By setting a low price, your network grows. In the next period, you may or may not increase the price. This will depend on the network size. Once the network is large enough, network effects are strong enough in their own right to provide value to consumers. They are willing to pay a higher price. You might get away with increasing prices and still being able to add consumers to the network. With network effects, optimal pricing is dynamic. Setting prices becomes more complex because we need to trade off profits today with profits in the future. To sum up, we've seen the three types of price discrimination and some notion of how and when to implement them in practice. We have recognized that network effects force you to think about pricing strategies as dynamic decisions. Thanks for watching.